Good day everyone, I am Harvie Jay. Today we will dive into Week 8 Program Flow Iteration Statement, an essential concept in programming that allows us to efficiently repeat a set of instructions under specific conditions. So basically, iteration statements, also known as loops, are the backbone of many programs, helping us automate repetitive tasks and solve problems more effectively. In these lessons, we will explore the different types of iteration statements such as for loops, while loops, and do while loops, along with their application syntax and practical example. So let's get started and unlock the power of loops in programming. This topic is crucial. Automating repetitive tasks and solving complex problems efficiently. So by the end of this session, you will be able to discuss the different iteration statements at their functions, demonstrate how to apply these iteration statements in solving real-world machine problems, and design and test your own iteration cases to ensure they work effectively. These outcomes will not only help you understand the theory behind loops, but and also gives you the hand-on skills to implement them in practical scenarios. Let's dive in and discover how iteration can simplify and optimize programming tasks. There are three main types of repetition control structures. We have while loop, do while loop, and for loop. Now to explain this, let's first go on with while loop. So basically, this loop runs as long as the condition is true, and it's commonly used when the number of repetitions isn't known in advance, like processing input until a user types exit. Now let's go to do while loop. It is similar to the while loop, but the key difference is that it runs the block of code at least once before checking the condition. This is useful for scenarios like displaying a menu to a user. Lastly, we have for loop. We all know that this loop is ideal when the number of iterations is predefined. For example, it is often used for tasks like iterating through an array or counting from 1 to 10. The while loop in Java is a control structure that repeats a block of code as long as a specified condition remains true. The syntax is simple, so we define a condition, and as long as that condition is true, the code inside the loop keeps running. Once the condition becomes false, the loop stops. For example, if you wanted to print numbers from 1 to 5, you could use a while loop. The loop would continue running as long as the count is less than or equal to 5. Once the count goes over 5, the loop stops. The while loop is best when you need to repeat something, and it is exactly how many times it will need to happen. The while loop in this example starts with x set to 0 and continues to run as long as the condition x less than 10 is true. In each iteration or loop, it prints the current value of x, then increments x by 1 or x++. This process repeats until x reaches 10, at which point the condition x less than 10 becomes false and the loop stops. The output will be numbers from 0 to 9 printed on per line or printed 1 per line.
Okay, while loop. Start natin with integer. Integer. Let's alt I para mabilisan na lang, and the value is 1. So far, while loop, let's call while statement. I is less than equal to 5. This condition is parang if statement, pero while siya. Tama. Is if si I pag less than and or equal siya to 5, then system that out dot print next line to number, then plus natin since ito yung looping plus 1 or I the integer. Then for I, then plus for the loop. Yan. Then if nirun natin siya, yan, maglo-loop lang siya until ma-hit niya yung 5. If 10 naman ang nilagay natin, and then yung maglo-loop siya until ma-hit na yung loop. Yun lang. That's for while loop. Slash while loop.
The dual loop is similar to the while loop, as I stated earlier, but with a key difference. The code inside the loop is executed at least once, even if the condition is false. So this happens because the condition is checked after the code runs, not before. The loop starts with the do block, which contains the statements to be repeated, and then checks the condition in the while part. So if the condition is true, the loop repeats. If it's false, the loop stops. So this structure is useful when you need the loop to run at least once, such as when prompting a user for input or performing an action before checking if it should continue. Now, the dual loop and while loop both repeats a block of code based on a condition, but the key difference is that the dual loop guarantees the code runs at least once, while the while loop checks the condition before running the code. In this example, the codes inside the dual loop runs at least once, printing the value of x and incrementing it, even if the condition is x less than 10 was false initially. The loop continues as long as x is less than 10. In this while loop example, the condition x less than 10 is checked before the code is executed, so the loop only runs if the condition is true initially. So basically, it will print numbers from 0 to 9. Both loops will output the same result, printing numbers from 0 to 9, but the dual loop ensures the code runs at least once even if the condition is false initially. When using a dual loop, it's important to remember a couple of things to avoid errors. First, don't forget to add semicolon at the end of while condition, as omitting it will cause syntax error. Secondly, just like any other loop, ensure that your dual loop will eventually terminate. Without proper control of the condition, you risk creating an infinite loop which can lead to performance issues or program crashes. Always make sure that the condition will eventually evaluate to false or include a break statement when necessary.
Hello, okay, start again. X na natin yan since tapos na tayo sa while loop. Okay, let's do while loop. Okay, so first, call it integer again, and let's call it I is equal to 1. 1, then, okay, call do system, sa do natin, system.out, out.print, next line, and number again, number plus 1 plus I, then have to call out the I, then plus para mag-loop, then puntalan I, puntalan, then have to call I, then the condition. Anong condition? The condition is if I is less than 5, or let's call it 10 para then gaano siya, yan, I plus, bakit error, print system.out print and do while loop. Okay, bakit ganun? Okay, yan, just like the while loop, naglagay lang tayo ng do statement or do while loop. So ang ang explanation here is ina-execute niya yung block at least once before checking the condition. So ito yung chine-check niya chine-check niya muna to bago yung condition. System print out, then after that is true, then pupunta siya sa condition. Yun lang. That's for do while loop.
The for loop is a control structure that allows you to execute the same block of code a specific number of times. It's ideal for situations where the number of iterations is known beforehand. The syntax is initialization expression. This sets up the loop variable, usually defining its starting value, or int I is equal to 0. We have loop condition, which means this condition is checked before each iteration if it evaluates if it's true or false, and if it's false, the loop stops. We have step expression. This updates the loop variable after each iteration, for example I++ to increment the value. The for loop is as structured and concise, making it easy to use for tasks like iterating through arrays or running a fixed number of repetition. The for loop in this example starts by initializing I to 0. The loop will continue running as long as the condition I less than 10 is true, and after each iteration, I is incremented by 1 using I++ inside the loop. The statement system outprint I prints the current value of I to the console. The loop begins at 0 and steps before I reaches 10, producing the output of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Each on new line. This structure ensures the code runs a fixed number of times, making it efficient and predictable.
Okay, next is for loop. For loop. For loop naman, tatawag tayo ng for and integer. Since for loop siya, sa loob na natin siya sa loob na tayo magtatawag ng integer natin. Integer I, let's call it I is equal to, or the value niya is 1, then semicolon, then after that we're gonna call the I and the condition. Anong condition natin is equal to is less than or equal to 5. Then the loop increment or tama ba? Increment is I++. Then after that system.out para ma-print yung output natin, print ln or next time ln number, then again number, then plus I, then that's done. That's for our code. Bakit ayaw niya na naman gumana? I++ in equal to I is less than and then I++. Come on. There's something wrong. Meron ako dun. Okay. Yun lang. And pag ginawa naman natin tong 10, magiging 10 yung is. Okay. Up to kahit ilan. Kahit 100, then 100 yung list. Yan. That's for loop. For loop yan.
Now let's move on to branching statements. So branching statements in Java are used to control the flow of execution in a program, allowing it to move to different parts based on specific conditions or requirements. Java provides three main branching statements. We have break, continue, and return. So for the break part, this statement is used to terminate a loop or a switch statement and transfer control outside of it. It has two forms, which is the unlabeled break and labeled break. So basically, the unlabeled break ends the nearest and closing loop or switch statement, while the labeled break used in nested loops to terminate a specific labeled loop rather than just innermost loop. Next one is the continue. So this statement skips the rest of the code in the current iteration of a loop and immediately sends control back to the start of the loop for the next iteration. And it is useful when you want to skip a certain iterations without ending the entire loop. Lastly, we have return. So this is used to exit a method, and it can optionally return a value to the calling method. So basically, it's essential for providing output from a method or stopping its execution when certain conditions are not, or certain conditions are met. So to explain more about the unlabeled break statement, it is used to exit the nearest loop or switch statement when a specific condition is met. So how it works with a for loop. The for loop starts with an initialization run as long as the test expression is true, and updates the loop variable after each iteration. Number 2 is that inside the loop, there's a condition if I is equal to 5 in this example. Number 3, when the condition is met, the break statement is executed, which immediately stops the loop and transfer the control to the code following the loop. So this is useful when you want to exit a loop early based on a certain criteria. In the example above, the loop will only print iterations up to 5 and then it will stop.
Okay, next is unlabeled break statement. For this one naman, let's call loop integer I is equal to 1. Ganun pa rin. Then I is less than or equal to 10. Then I plus after that, if it's called if I is equal to 5, then break. For this code naman, then lagay tayo ng system that out that print and then it's called the I variable for this. Okay. For this naman, chine-check niya muna if the loop or existing loop is true, and pag na-meet niya yung condition na yun, magbe-break yung loop na yun. Okay? Like that. 5. Okay? Pag ginawa natin 10. 9, 10. Then it is 20. Is greater or 20, 10. 10, then 10, 20. Yan. 10, 20. Then, kasi 10 tayo nagsimula. Yun lang. That's for unlabeled break statement. Again, chine-check niya muna if yung loop condition is true, then after the condition is met, ini-break niya. That's why it's here. Ayan. Kasi pag hindi niya break, example 20, magiging 20 siya, pero pag nag-break ka or break ka, that's all for unlabeled break statement.
So to explain the labeled break statement, basically it is used to exit a specific outer loop in a nested loop structure. By labeling a loop, you can explicitly direct the break statement to terminate that labeled loop, not just the innermost one. So the outer loop is the label for the outer loop. So inside the nested loops, if the condition is I is equal to 1 and j is equal to 1 is true, then the break outer loop statement is executed. So this immediately stops both the inner and outer loops, skipping any remaining iterations of the either loop. Without the labeled break, the break statement would only terminate the innermost loop. The labeled break is useful for breaking out of multiple levels of loops efficiently when certain conditions are met.
Okay, start recording. Labeled state, slash labeled break statement naman tayo. As for this, first gagawa muna tayo ng outer loop or outer loop. I is equal to 1, then I is less than is equal to 3. Then I dito na lahat ng condition natin sa for na to. For I is equal to yan, okay. Teacher, then another for our outer or inner loop pala, let's just copy this and paste it here, then change ang variable. Okay, then after that let's call if na tayo, and condition natin if I is equal to 3, let's say 3 or 2 na lang, sige, para mabilis. 2 and J is equal to 2. Then break for break outer loop. It's called our outer loop an outer loop. Break the outer loop. Yan ang label natin. Nilabel natin yung outer loop natin as an outer loop, which is ito. Ayan. Then outer loop. Then system that out that print 9 I is equal to plus I plus then J is equal to plus J. Tama ba? Oops. I is equal to I, then plus pala natin. Plus I. J is equal to J, then there. Yun. Okay. Then system, mag-call out naman ulit ng system, and then for exited outer loop, para magpiprint to pag nag-exit na ng outer loop. Okay, let's run it. Okay, yan. So bale ang explanation here is mag-exit siya or magbe-break yung outer loop, which is here pag na-meet niya yung condition, and yung condition na yun na nilagay natin sa if natin is 1 is equal to 2. So if I is equal to 2, or next nito is I is equal to 2 and J is equal to 2, which is also here, magbe-break yung outer loop. Now if we change that to 3 and 3, magpapakita yung 2 2 2 3 3 1 3 2, and then di na magpapakita yung 3 3 or I is equal to 3 and J is equal to 3 kasi nga na-meet niya na yung condition, which is itong if. And if na-meet niya yung condition na yon, then magbe-break yung outer loop, which is ito. I-run niya yan. Then mag-run din ito, exited outer loop. And that's all for label break statement.
The continuous statement is used within the loop to skip the current iteration and moves to the next one, effectively bypassing the remaining code in the loop for that particular cycle. This helps when you want to skip certain conditions without terminating the loop entirely.
Okay, next for our next example is continue. What is continue? So first, maglalapag tayo ng loop. As for loop natin, int I is equal to 1. I 1 usual. Then I is less than or less than then 5. Okay. Then I plus then magtatawag na tayo ng condition. Now na nagawa na natin yung loop natin, tatawag tayo ng condition. If our condition, if I is equal to 3, then continue. Then magtawag tayo ng system dot out dot print, and para mag-print yung loop natin, number, then plus I. Yan. So ang ginagawa ng continue is ini-skip niya lang yung ini-skip niya or ini-skip niya yung code for that iteration. For example, pag nirun natin to is 1, 2, then ini-skip niya yung number 3 kasi sa condition natin is nakalagay I is equal to number 3. So, ini-skip niya yan. Skip. Yan. Ni-skips niya yung na yan. Then, continue the run. Pag nilagay natin 10, yan. Yan. Number, then, ni-skip niya yung number 3. Or, tinatanggal niya yun. Hindi niya piniprint yung number 3 for that. And that is continue. Pag change naman natin to number 10, yan, hindi niya print yung number 10 kasi ini-skips niya. And that is for continue.
On the other hand, the return statement is used to exit a method and optionally return a value to the calling method. If a method is expected to return a value, the return statement provides the value. Now, if the method is void return can be used to the exit method early without returning anything.
Okay, let's proceed for the last example for lesson 8 is return. So for return naman, ang gagawin natin is magtatawag tayo ng integer. Integer is equal to add. Na another add or another, nagtawag tayo ng integer. Nagtawag tayo ng variable sa variable. And yung value nito is 7. Dito nag-i-store ng natin, ng value. Itong method na to ito siya yung nag-i-store ng value natin, which is nagagamitin natin mamaya. Then tawag tayo ng system dot out dot print and then sum plus sum. For this naman, siya yung nagpiprint ng sum natin. Yan, sum. Then, magtatawag tayo ng public static for add natin. As for that is siguro here, public static, then integer add para dito natin. Add, then int a and int b. Then tatawag na tayo ng return a plus b. Yan. Yun. Gumaan na ba? Ayan. So, bale, yung method na to is, ina-add niya lang yung dalawa and i-return niya dun sa results, which is here. So, nandito yung store natin, which is yung, kung nakapaloob yung value natin, and nandito yung, ina-add niya yung value, which is pag naran natin, yung sum natin is magiging 10, which is, kasi nga, dito natin in-add, or, yung value natin here, is pinag-add natin, and ni-return lang nitong code na to, dito. Kasi ang nakalagay, int sum is equal to add, which is yung add natin na variable is nandito. Okay? So, bali ito, nare-return niya lang. Return the sum of A and B. Nare-return na doon. Then, yun na. Let's return.
So, basically, both statements are essential for controlling the flow of execution in loops and method. Now, that brings us to the ends of today's session on iteration statements and branching statements. We've covered how loops like while, do while, and for loops allow us to repeat code efficiently, and how branching statements like break, continue, and return helps us control flow of our program. Remember that these concepts are essential for writing clean, effective Java programs. So by understanding how to manage loop and control statements, you can solve complex problems and build better programs. Thank you for your attention, and if you have any questions, feel free to ask. Again, I am Harvie Jay Ballesteros from SBIT1E. Thank you for watching and for listening.